Hello, my lovely friend. Today I come to you with a new challenging geometry problem. Here it says find the shaded area of this graph. Oh, pause the video and think about it. 3, 2, 1. Okay, let's start. We are gonna find the area of this region, and I have only two graphs, and the function of this graph, I have an expression of these two graphs. We don't have any certain formula for this region. So I know I recall integral. Integral always gives me the area of the graph between the graph and x-axis. But here I have two graphs. They have an intersect at 1 and intersect at -1. And I am gonna find the area of this region between -1 and 1. The upper graph is this graph, blue one, and the lower graph here between -1 and 1 is red one. Okay, I try to get integral. So integral from -1 to 1. Here the upper one is this graph, which is x to the power of 4 minus 4x squared. Okay, x squared plus 1. Now minus the lower graph, which is minus x squared minus 3 dx. That dx I have to apply for all these expressions. So I put this expression inside the parentheses. Okay, first I try to distribute this negative sign inside parentheses. So it would be negative, it would be positive, and change the sign of this negative. Okay, I will write it again from -1 to +1. This integral is from -1 to +1. How many terms of x to the power of 4 do we have? Only one term. I write it x to the power of 4. And for x squared, I have two terms. -4x squared minus x squared gives me -5x squared. And how many constant terms do we have? 3 plus 1 gives me 4. I put all this expression inside the parentheses and then the x. Okay, now I try to take an antiderivative. So antiderivative for the first terms would be x. I add a 1 to the power, which is x to the power of 5. I bring 5 to the denominator, and then my coefficient is 1. I will go for the next one, x to the power of 2. So x to the power of, I add a 1 to the power, x to the power of 3. And then bring this 3 to the denominator. And then put the coefficient. I put 5 as a numerator. Here 4, if I see the constant, I should know multiply by x to the power of 0. We know x to the power of 0 gives me 1. So I say it was 4x to the power of 0. Okay? So I add up 1 to my power. Let me write x to the power 0 plus 1 gives me x to the power of 1. And then bring 1 to the denominator. And then put the coefficient, which is 4. I know I never mentioned 1 as a denominator and exponent. Anyway, I write it. Now I have to apply my limit from the lower limit and upper limit to find the value of this region, the area of this region. Okay, I start from upper. I have to start from upper. If I substitute 1 in this expression, I will have 1/5 x to the power of 1 to the power of 5 gives me 1, so it would be, first term would be 1/5 minus 5/3. 1 to the power of 3 gives me 1. 1 times 5/3 gives me 5/3 plus 4 times 1 gives me 4. I will go for the lower limit and substitute -1 inside this expression. So minus, now lower limit, -1 to the power of 5 gives me -1. So it would be -1 over 5 minus 5/3. -1 to the power of 3 gives me -1. So -5/3 times -1 gives me 5/3, positive 5/3. Now I will go for the next one. -1 here, -1 times 4 gives me -4. Now I distribute this negative inside this parentheses and change the sign of all the term. It would be, I make it positive, negative gives me positive. It would be negative, so I eliminate this positive. It would be positive. Let me change it. It would be positive, negative, and for the third one becomes positive again. So it would be positive. And then change this sign as well. So I have 1 over 5 plus 1 over 5 gives me 2/5. And this negative 5/3 plus negative 5/3 plus negative 5/3 gives me -10/3. Positive 4 and positive 4 gives me 8. Okay, if I take a lowest denominator here would be 15, and it would be 6. It would be -50 plus 8. And now I say -15 plus 6 gives me -44 over 15 plus 8. If I find this value, 8 minus 44 over 15 gives me 5.067. So the area of this region would be, the area of this region equals 5.067. We are done here. You see how much is easy. So if you like it, subscribe, share with your friends, and stay tuned. I will see you in the next new problem. Bye bye for now.